Hi, this tutorial covers and probability for dependent events. All right, let's start with some statistics. So, 5% of all high school basketball, baseball, and football players go on to play their sport in college. Of these players, 1.7% go on to play their sport professionally. Additionally, 0.01% of high school athletes who did not compete in college will play professionally. So let's denote two events. Let event C be the event a high school athlete will play in college. Let event P be the event that a high school athlete will eventually play professionally. All right. So let's notate each of these probabilities. Okay, we're using C and P. All right, so the 5%, so it's the 5% of these athletes go on to play their sport in college. Okay, what this is just the probability of event C is equal to 0.05. Okay, now of these players, 1.7% go on to play professionally. Okay, now we're not looking at all high school athletes now. Now we're only looking at the collegiate athletes. Okay, so what this number is going to be is it's going to be the probability of professional given collegiate. So if a student or if a athlete played their sport in college, there's a 0.017 probability that they'll also play professionally. Okay, so it's the probability of professional given college. Okay, now additionally, 0.1% of high school athletes who did not compete in college will play professionally. Now, what the condition is this case is this is now the probability of professional given the complement of college, so not playing in college. Okay, and then this, so it's 0.01%, so that's 0.0001 as a probability. Okay, so now let's go ahead and use a tree diagram to display the sample space of the outcomes of a randomly selected high school athlete. Okay, so our outcomes here are first going to be college or not college. Okay, so the high school athlete's either going to play in college or not play in college. Okay, then they can either play professionally or not professionally. Okay, now what's nice about tree diagrams is you can assign probabilities to the branches of the tree that will represent the different outcomes. Okay, so we said that there are 5% of athletes, of high school athletes, that go on to play in college. So what I'm going to do is put 0.05 along that branch. Okay, that means there's a 5% probability that an athlete will play in college. And there then is a 0.95 chance that they won't play in college. Okay, so these two numbers here need to add to 1, and they do. Okay, now since playing in college and playing professionally are dependent events, you're much more likely to play professionally if you played in college than if you're not. The probabilities that go on these branches need to be conditional probabilities. So the probability that goes here is the probability of pro given college. Okay, and we do know that number. That number is 0.017. Okay, so there is a 0.017 probability of playing in or playing professionally given played in college. Okay, so the number that needs to go here then is 0.983. So that number comes from 1 minus 0.017. Okay. Now the other number we know is the probability of professional given the complement of college. So playing in the pros if you didn't play in college. Okay, and that number was 0.0001. Okay, so then what this needs to be is 1.9999. Okay, so these two can add up to 1. Okay, so that is my tree diagram, and each of the 4 outcomes are listed. Okay, so now we'll come back to this tree diagram because this is going to be helpful when we actually calculate probabilities of the four events. But let's start with kind of the formula that we're going to use to calculate these probabilities. All right, so the first rule here, the special multiplication rule, hopefully you've seen before. It says if events A and B are independent, the probability of A and B equals the probability of A times the probability of B. Okay, so we said that playing in college and playing professionally are not independent, so they're dependent, so we cannot use the special multiplication rule here. Okay, so what we need to use instead is what's called the general multiplication rule. Notice that this one doesn't have a condition. This one can be applied to any situation. So this is the probability of A and B equals the probability of A times the probability of B given A. Okay, so let's now apply the general multiplication rule to a couple probabilities. Okay, so let's start with the probability of C and P. Okay, we could also use the symbol, the and symbol here if we wanted to. So according to the general multiplication rule, probability of A and B is the probability of A times the probability of B given A. So it's B given A. Okay, so if we apply that to this is going to be the probability of C times the probability of P given C. So the probability of playing in college times the probability of playing professionally given playing in college. Okay, so C and P, that is this outcome here, college and pro. So we're looking at this outcome. Now, to get that, we said you'd take the probability of playing in college times the probability of playing professional given college. So really, if we just multiply down the tree, multiply this probability times this probability, that's going to match our formula. Okay, so this will end up being 0.05 times 0.017. Okay, and we'll do that in the calculator. Okay, and that's going to give me, so that's scientific notation there. So the E negative 4 means times 10 to the negative fourth. So if I write that out, it's going to be 0.00085. Okay, so a pretty small chance that a high school athlete will both play in college and play professionally. Okay, so now let's calculate another probability. The probability of not playing in college and not playing in the professionally. Okay, so again, if we use our formula, it's going to be the probability of not playing in college times the probability of not playing in the pros given not playing in college. Okay, so if we go back to the tree diagram, this is helpful. We're talking about this outcome here, not playing in college and not playing professionally. Okay, so we're again going to multiply down the tree because that's going to be the same as applying the formula. So it'll end up being 0.95 times 0.9999. Okay, and if we do that, 0.95 times 0.9999, sorry, 4 nines, and that ends up giving us 0.9499 if we round that to the nearest value there. Okay, so almost a 95% chance that an athlete will not play in college and not play in the pros. So these were a couple examples of applying the general multiplication rule, which again helps us calculate and probabilities for dependent events. So that has been your tutorial on and probability for dependent events. Thanks for watching.